In this video, we're going to be discussing how to create a quadratic equation that matches a table of values. So first, let's say we have this table right here, where here we have some x values, here we have some y values or f of x values, and you're given this question: what type of function does this table match? So you need to first look for a pattern. One thing you could do is you could create a difference column here and see if there's a pattern there. So from 3 to 4, there's a plus 1. From 4 to 13, plus 4 to 17 plus 13, to go from 17 plus what to get me 42. That'd be a plus 25. And from 42 to 79, that'd be a plus 37. Okay, so they're not exactly the same number or anything, but if you're looking at this, you might notice that if you created a second difference column and you did the difference of your difference column to go from 1 to 13, well, that's plus 12. 13 to 25 is also plus 12, and a plus 12 between those two numbers. So if your second difference column are all the same numbers, it's plus the same number, plus the same number, plus the same number, then you have a quadratic. Okay, so now that you know that this table right there, that portion, that table matches a quadratic, how could you create a closed equation that matches your values, your table? Okay, so first let's look at your general equation for a quadratic. So your general equation for a quadratic is your y, or your f of x, is equal to some number a times x squared plus some number b multiplied by x plus some number c. So if you can find a, b, and c, then you have your equation for the quadratic. So let's go over how to find each of these individually. So first, let's find a. Your value for your a will equal your second difference column divided by 2. So here your second difference column, your triangle squared column, is positive 12. So a is equal to positive 12 divided by 2. So therefore your a is equal to 6. All right. Next, and this 12 right here, let's put it in green. All right. Now that you have your a value, let's find our c value. So your c value, I shall put that, let's do that right here. Your c value is equal to your y when x is equal to 0. In other words, it is this number right here. So your c is when x is 0, what is your y? So in this case, my c is equal to 3. All right, so now you have your a, you have your c, and now we just need to find our b. Well, in order to do that, what you could do is pick any other pair of values here and substitute that into your equation for your quadratic, along with the values for a and b. So let's do that. Those of you taking notes, let's put this sort of in an order. So first I found my a, then I found my c. So this would be sort of a step 1 here, and then step 2. Okay, now here, step 3, let's determine our b. We have our equation here. And we're going to substitute. All right, let's change our c into 3. Let's change our a into 6. And now we need to pick which pair of values are we going to use. Personally, I'm going to choose to use the small pair. I'm not going to use this pair since we already used this pair to find our c. Let's use this pair. On top of that, if you plug this in, you would not be able to find your b. It would just end up, your equation right here would just end up becoming 3 equals 3. So let's plug in another pair of values here, and I'm going to choose to use the small one. And let's highlight this yellow. Sure. So I'm going to use this yellow value here. Let's pick a different color. Gray. Okay. So let's pick this value right here. So now I'm going to change all my x's into 1. And when x equals 1, my f of x is 4. So I shall change my f of x to 4. So now you have an equation where there's only one variable, b, and everything else is a number. So now just solve for b. Let's put a little bit of, give myself some space here. All right, well, 4 in parentheses is the same as 4 without parentheses. Let's look at this term right here. 6 times 1 squared, or 6 times 1 times 1. Well, 1 squared is just 1, and 1 times 6 is 6. So this term is 6. B times 1 is just b. 3 in parentheses, same as 3 without parentheses. Okay, continue to simplify. I can switch the order here. So 6 plus b, same as b plus 6, sure. And positive 6 plus 3 is 9. Let's continue. Subtract 9 from both sides. B plus 9 minus 9 becomes b plus 0. And b plus 0 is the same as b. 4 minus 9 is negative 5. Here we go. So now we have our 3 values here. We have a is 6, c is 3, b is negative 5. So I guess your step 4, write the equation. Sure. B is negative 5. Your C was positive 3. Your A was 6. 6, 3. Okay. In the most, technically, as a teacher, I like to, when you're substituting things in, I should substitute it in with, in a parentheses. but honestly, the parentheses doesn't do anything in this situation. Your 6 in parentheses times x squared is just 6x squared. Your 3 in parentheses in a term by itself is just a 3. And this parentheses also doesn't do anything. You can further simplify this because plus a negative is the same as just saying subtract. So there you go. You have your equation for a quadratic that goes through these points. All right, let's do one more example. So let's say we have this particular table of values. And once again, you're asked, what type of function does this table match? I shall once again create a difference column. And the difference between these two, or 16 plus what gets me 29, that's 13. 29 plus what gets me 44, that's plus 15. 44 plus 17 gets me 61. 61 plus 19 gets me 80. And my second difference column, it's a positive 2, positive 2, positive 2. 13 plus 2, 15. 15 plus 2, 17. 17 plus 2, 19. So once again, because my second difference column is always plus, plus, plus the same number, this is a quadratic. Right? Now I'm going to write a closed equation for this quadratic. This is g of x is equal to some number a, x squared plus b times x plus c. And I just have a letter g here because that's what's given in my table. Okay, so sure, let's go step 1. Determine a. Okay, I once again know my a is equal to my second difference column divided by 2. My second difference column is a number 2, positive. So I shall divide that by 2. And once again, this 2 is from right there. And obviously 2 divided by 2 is 1. There you go. I've figured out my a. Step 2. Determine my c. And once again, my c is my y value when x is equal to 0. Okay. Oh, look, on this particular table, I do not have x equal 0. So what I need to do, I need to go backwards until I get there. So let's insert a row. Cool. Okay. So using this pattern, if this is 6, 5, 4, 3, 2, I notice that this is minus 1, minus 1, minus 1 each time. So therefore, this is 1 and 0. All right. I know this second difference column is always going to be positive 2. All right. So now I need to go, I'm basically kind of going backwards. I'm starting here in the right column and then going towards the left column. So I know that the way I got these number 2's here was I said 13 plus what gets me 15. 15 plus what gets me 17. 17 plus what gets me 19. You can also think of this since when I was heading in this down direction, let me do that again. So when I was heading in this direction. 13 plus 2 gave me 15. 15 plus 2 gave me 17. 17 plus 2 gave me 19. And this was all pluses going in the down direction. Going in the up direction, I can think of it as subtraction. So 19 minus this 2 gave me 17. 17 minus this 2 gives me 15. 15 minus this 2 gives me 13. 13 minus this 2 would give me 11 here. 11 minus this 2 gives me 9 here. Okay, so we have now gone backwards to fill in these two columns. So same sort of deal to fill in my g of x. Originally, I thought of this as 16 plus 13 to get me 29. 29 plus 15 to get me 44. 44 plus 17 is 61. 61 plus 19 gets me an even 80. So going down, I was adding. So 80 minus 19 is 61. 61 minus 17 is 44. I'm doing the opposite of what I did when I went down. 44 minus 15 is 29. 29 minus 13 is 16. 16 minus 11 is 5. And 5 minus 9 is negative 4. All right, now that I've done all that, I now have my y value. And now I have my y value when x is equal to 0. So, therefore, my c is equal to negative 4. And I guess I didn't explain why that actually works earlier, but just so you know, if you have this equation, and I were to change all my x's to 0, well, 0 squared times a is just 0. B times 0 is 0. And it's just because 0 multiplied by anything becomes 0. And 0 plus 0 plus c is just c. So if my x is 0, then c is equal to my y value. And that's the reasoning why this part right here works, by the way. So you have your a is 1, c is negative 4, and now you just need to find your b value. So step 3, determine your b value by substituting. And this part will just be like earlier. Your c was negative 4. Your a value was 1, and that's just me getting a equals 1, c equals negative 4. All right, and now I need to pick any of the other pairs of values. Because I am the one that came up with this 1, 5, I'm going to choose not to use that. I'd rather use one of the original ones. These were the original 5 pairs that I was given. I'd rather use one of them. That way, if I made any mistake when I was coming up with the 1, 5, hopefully I'll see the mistake when I try to use one of their values. And obviously I will not use this one because I've already used that one, and if I plug that in, it's just going to get me negative 4 equal negative 4. Okay, so I'm going to choose, I think I'm going to actually choose 6 comma 80. And that's because since this 80 ends in a 0, uh, I think it's going to be a nice number for me to use. So I choose to use these. You could have chosen to use any of the other 4 pairs. I'm going to choose 6 and 80. So I shall change all my x's to 6. I shall change my y into 80. Now we have an equation where there's only one variable. Your b. So let's start simplifying. So 6 squared times 1. Or this is 1 times 6 squared. So 1 times 6 times 6. 6 times 6 is 36. 36 times 1 is still 36. B times 6 is generally written like this, 6b, or 6 times b. And plus negative 4 in parentheses is just the same as plus negative 4 not in parentheses. And this whole plus a negative, I can just write as a subtraction. Okay, so simplified it a little bit. Let's keep on. Since this is 36 plus 6b, I'm allowed to, when you have adding, you can switch the order, like 1 plus 2 is the same as 2 plus 1. 36 plus 6b is the same as 6b plus 36. And positive 36 minus 4 is 32. In order to solve for b, I need to get rid of this plus 32 and just multiply 6. I'm going to choose to get rid of this first. And by get rid of, I mean get rid of it from the right side where the b is. So I'm going to minus 32 from both sides. Positive 32 minus 32 just becomes 0. And 6b plus 0 is the same as 6b. 80 minus 32 is 48. All right. So now we have 6 multiply b. The opposite of multiply b is divide. Sorry, opposite of multiply times 6 is divide 6. So each of these I'll just divide by 6, each side of the equation. All right, so 6 divided by 6 is just 1. So 6b divided by 6 is just 1b. 48 divided by 6 is just 8. And just a little quick reminder that 1 times 1b, or 1 times b, is the same as just saying b. So my b is equal to 8. There we go. So now we have our a, b, and c. So just create the quadratic equation, or create the equation. And my a will be 1, c will be negative 4. A is 1, c is negative 4, b is 8. And once again, I'm substituting in by writing it in parentheses because that is the best way to make sure you don't make a mistake, but it isn't 100% necessary, not all the time. Okay, so 1 in parentheses times x squared is just, you can just write that as x squared, because multiplying times 1 does not change anything. 8 in parentheses times x is just 8x like this. This still says 8 times x. And plus negative 4 in parentheses is the same as plus negative 4 without a parentheses. And my plus negative, I can just simplify to a subtraction sign. So here you go. this is the equation for a quadratic that goes through these 5 points that we started with.